Today I'm going to be working on a few problems that deal with absolute values in equations. Now in your lesson you probably noticed that the word honors appears after the title of absolute value equations. I just want to reassure you that absolute values are not just for honors students, they're for everybody. So that is why we're going through them today. It is important that everybody knows how to deal with absolute value equations and the importance of them. So to start things off, we need to know that there can be more than one answer for your absolute value equation. Right? We're going to have, what we do is we're going to set up two different systems to solve. Okay? The first equation, we're just going to write it without any absolute value signs. Now, I want to make sure that the absolute value signs are kind of isolated on the left-hand side here. And they are. We have s plus 3. So how I'm going to write this is just s plus 3 equals positive 9. Now because those are isolated, I can also write s plus 3 equals negative 9. Notice I'm always going to take the opposite of whatever value is on my right-hand side. So because this is positive 9, I made it a negative 9. And then I'm going to go ahead and I'm going to solve for s in each of these equations. So to do that, I'm going to start by subtracting 3. So in my first equation, I get s equals 6. In my second equation, I get s equals negative 12. And both of these are actually solutions to my problem, because when I substitute them back in, 6 plus 3 is 9. The absolute value of 9 is positive 9. And negative 12 plus 3 is negative 9. And the absolute value of negative 9 is also positive 9. So both of those work. In my next problem here, I can't just set up my equations right away. I need to isolate that absolute value sign. So what I'm going to do is I am going to start by subtracting 9 from both sides. So I get a negative absolute value of 7a equals a negative 49. Now I got to get rid of that negative sign in front of the absolute value sign also. So if I go ahead and multiply everything by negative 1, I get my absolute value of 7a equals a positive 49. Okay. Now that I have the absolute value sign isolated here, I can set up my two equations. So I can have 7a equals positive 49, or I can have 7a equals negative 49. And to solve for a in each of these equations, we're going to divide by 7. So in my first equation, I get a equals positive 7. And in my second equation, I get a equals negative 7. So my two answers here are positive 7 and negative 7. Okay, again, let's work on isolating just the absolute value sign. So here's my absolute value sign. We need to do the inverse of dividing by 7. So the inverse of that would be multiplying by 7. So I would get the absolute value of n plus 49. It equals 10 times 7, which is 70. And now I can go ahead and rewrite my two equations. So the first equation that I can come up with is n plus 49 equals 70, and n plus 49 equals negative 70. Okay. To isolate n, we're going to subtract 49 in both cases. And here we would get n equals a positive 21 for the first one. And in the second one here, let's see what we get here. N equals a negative Negative 119 it looks like. So a positive 21 or a negative 119. And the last problem I'm going to go through here today, it looks like our absolute value sign is already isolated, so I'm just going to go ahead and rewrite my two equations. So t divided by 3 minus 3 equals 5. And then my second equation is t divided by 3 minus 3 equals negative 5. Okay, I'm going to start by adding 3 in both equations. So that would leave me with t divided by 3 equals 8 in my first one. And let's go ahead and multiply each side by 3. So 8 times 3 is 24. So 24 is my first answer. Let's see what we would get in our second equation. So if I'm adding 3 to both sides, that leaves me with t divided by 3 equaling negative 2. And if I multiply each side by 3, I get t equals negative 6 for my second answer.